Bismillahirrahmanirrahim. Hi, how are you doing, guys? We will complete the exam view problems, the second part, number 21. A golf club hits a golf ball with a force 2400 Newton, sending the ball into the air. The force exerted by the club by the ball or on the ball must be less than 2400 Newton, or else the ball wouldn't have moved forward. Guys, for any action there is an equal and opposite reaction. So this is sentence false because both forces are exactly equal. So the answer is letter B. Number 2, the figure shows two boxes with M1 larger than greater than M2 that are on a level frictionless surface. We can apply horizontal force F either toward the right on M1, so it will be like that, or toward the left on M2, so it would be like that. The magnitude of the force that boxes exert on each other, so from M1 on M2 or from M2 on M1, is, he said, 0, larger, the same. Let's analyze that. At the beginning, if you exert a force F from left or right, F equal the mass of the two boxes M1 plus M2 times acceleration. So always acceleration be F over M1 plus M2. Let's try something. If F to the right, so to the right on M1. So M1 will apply a force. Let's give it a symbol F small 1. This is to the right. Equals from M1 on M2. So equals M2A. The acceleration will be the same as we got it before. So F1, this is to the right, equals M2 F over M1 plus M2. Put in your mind M2 is small. Let's try to the left. So F, we call it F2 from mass 2 on mass 1 equals on mass 1, so M1A. So M1 times F over M1 plus M2. Which is larger? F1 to the right or F2 to the left? Put in your mind that M1 larger than M2. So F2 larger than F1 because M1 is larger than M2. F2 was to the left. So larger, the answer will be larger if F is applied toward the left, to the left. Because as you see here, M1 is larger than M2. So F2 from the box, small box on M1 is larger than F1 from box M1 on M2. So the answer is C. I hope you understood this problem. Let's go to next one. A horse pulls on a cart. This is the horse. Sorry about the drawing. And this is the cart. With force F. As a result of this force, the cart accelerates with constant acceleration. There is acceleration. The magnitude of the forces that the cart exerts on the horse, for any action, there is an equal and opposite reaction, guys. So equal to the magnitude of F. So the answer is B. Let's go directly to 24. An object of weight W is in free fall close to the surface of the earth. The magnitude of the forces that the object exerts on earth is the magnitude of the force that the object exerts on the earth exactly equal the magnitude of the force exerted by the earth on the object. Right, guys? So the answer is C. Next one, 25. An object of mass m rests on a flat table. This is the table, and this is the object of mass m. The earth pulls on this object with a force of magnitude mg. So this is the weight by the earth. Right, guys? What is the reaction force to this pull? The earth pull the object with a force mg. The earth pulls the object with a force mg. So the object pulled the earth with a force exactly equal mg. The object and pulling upward. The object pulling upward on the earth with a force mg. Here he doesn't speak about the floor. We are speaking about the earth. The earth, the object pulls. The earth pulls on this object with a force of magnitude mg. The relation between the object and the earth. So the reaction between earth and the object and in opposite direction. So the answer is D. Next one. You are standing in a moving bus. You are standing in a moving bus. Facing forward, facing forward. Here is the driver. When you suddenly slide forward, as the bus comes to an immediate stop because of inertia, your body was at a moving state of motion, and wants to complete motion. What force causes you to slide forward? There is no force, guys. This is because of inertia. There is not a force causing you to slide forward. That happened because of inertia. The object at rest wants to stay at rest, and the object in a state of motion wants to continue in a state of motion. Inertia is the tendency of an object to resist any change in a state of motion. So there is no force for that. So the answer is D. Let's go to number 27. A fireman is sliding down a fire pole. A fireman is sliding down a fire pole. As he speeds up, sliding down, he speeds up, he tightens his grip on the pole, thus increasing the vertical friction force that his pole exerts on the fireman. When the force on his hands equals his weight, what happens to the fireman? equals his weight, so the amount of force, the net force, equal 0. So there is no acceleration. Acceleration equals 0. Acceleration equals 0 means constant velocity or constant speed downward. So the fireman comes to stop. Why? The fireman descends with slower and slower speed? No, the fireman descends with a smaller but non-zero acceleration? No, zero acceleration. The fireman continues to descend but with constant speed? Yes. Constant speed means zero acceleration because the net force equals 0, the acceleration equals 0, the speed is constant. So the answer is D. Let's go to number 28. A person is using a rope to lower 5 Newton bucket into a well. With a constant speed, constant speed means the acceleration equals 0, means the net force equals 0. What is the magnitude of the force exerted by the rope on the bucket? The same as this force. To get a total amount of net force equals 0. That's it. Why I said that? Because the word constant, the acceleration is 0. So the answer is C. 29. A person who normally weighs 700 Newton is riding in a rather swift elevator, 700 Newton, that is moving at constant speed, acceleration equals 0, the net force equals 0. If this person is standing on a bathroom scale inside the elevator, and he weighs 700 Newton, what would the scale read, like the tension or the apparent weight? So exactly equals 700. Why? Because the net force equals 0. From where I got it? From acceleration equals 0, from constant speed. So the answer is 700. Let's go to the next. A person who normally weighs 700 Newton is riding in an elevator that is moving upward but slowing down. Moving upward but slowing down, so A, negative. At steady rate, if this person is standing on a bathroom scale inside the elevator, what would the scale read? More than, less than, equal 700. Let's analyze it together, solve it together. Here is the weight, 700. The elevator is going upward, so the direction of the motion upward. So MAY equals the apparent weight minus 700. So WA equals MAY plus 700. But put in your mind that the acceleration is negative. So the apparent weight will be less than 700 by the amount MAY, right? So WA is less than 700 by the amount of MAY, because A, the acceleration here, is negative. We can write it like that: WA equals 700 plus MAY, but put in your mind this is negative. So the apparent weight will be less than 700. So the answer is less than 700, B. Let's go to the other one. 700 Newton box rests on perfectly smooth horizontal surface. Smooth horizontal surface. This is smooth. There is no friction, guys. So the minimum force needs to start the box moving. Any force can move it because there is no friction. It doesn't need a huge amount. Any horizontal force greater than zero. Why? Because there is no friction. So the answer is D. Let's go to the next. 32. The acceleration due to the gravity is lower than on the moon. You know that the acceleration of gravity on the moon 1/6 the acceleration of gravity on Earth. Which one of the following statements is true about the mass and weight of an instrument on the moon's surface compared to Earth? You know that mass is constant. The amount of matter inside your body is constant, guys. But weight changes. Weight equal mg. If g on the moon is less than g on Earth, so your weight on the moon is less than your weight on the Earth. So mass is the same, weight is less. So the answer is B. Let's go to next. When 45 kilogram person steps on a scale in an elevator, the scales read a steady 480 Newton. So the apparent weight is larger than the weight because the weight equal mg, the weight equal m. 45 times 9.8, let's solve it. 45 times 9.8 equals 441. 441. So the apparent weight larger than the weight. So let's check. When WA is larger than W, imagine that the elevator is going up. So this is Fy, right? So, and this is W, and this is WA, apparent weight. So MAY, we are imagining that the elevator going up equals WA minus W, or what we call it mg. So send this other side, WA, the apparent weight, equal mg plus MAY. So WA is larger than W with amount MAY. So the elevator is going up. The elevator is accelerating upward, right? But I want to say something. What if the elevator is going downward with decreasing acceleration? I'll give you the other case. This is the weight, and this is WA, the apparent weight, and the elevator is going down. So FAY down, FY down. So MAY equals W minus WA. MAY equal W means mg minus WA. So WA equal mg minus MAY. What if the acceleration is negative? So you will say WA equal mg W plus MAY because acceleration is negative. So it may be the object or the elevator is going up with increasing speed, with increasing speed means acceleration, or going down with slowing speed, or means with deceleration. So from the given information, we cannot tell if the elevator is moving up or down. So the answers may be letter A plus letter E. Two answers here. Let's take another one. When 45 kilogram person steps on a scale in an elevator, the scale reads a 410. The same problem, I think. No, 410. The one before, it was 480. Let's find something. W equal mg equal 45 times 9.8 means 441 Newton. That means the apparent weight is less than the weight, 410. So let's imagine something. This is the elevator. Imagine it is going downward. Okay? So Fy downward. This is the weight, mg, and this is the apparent weight, Wa. So MAY equals mg minus Wa. So WA equal mg minus MAY, or W minus MAY. So WA is less than W, right? So the elevator is going downward. It works. So the answer is B. The elevator is accelerating downward at a constant rate. But there is another case. Imagine that the elevator is going upward with, it is slowing down, decelerate. Let's try it. This is Fy. So MAY equal, here is W, and here WA. WA minus W. So WA equals W plus MAY. But what if AY negative? So now WA is less than W, because all this amount will be negative. So the elevator may be going up, but decelerate, or going down. So from the information here, we cannot tell if the elevator is moving upward or downward. So the answer E is also right. I hope you got it. Let's go to solve the next. 35. Inside the train, a ball of weight W is hanging by a light wire, as in the picture here, from the ceiling. The wire makes an angle theta with the ceiling, as shown in the figure. Which one of the following conditions must be true about the tension? So this is the wire. Okay, the tension is here, T, and this is theta. So this is the weight, right? And let's resolve the tension in two components. T, theta is here, guys, right? From mathematics, theta is here, T cosine theta, and here T sine theta. Okay? So T sine theta equals W. So W equal T sine theta. The answer is A. Let's solve the next. In the figure, 10-pound weight is suspended from two spring scales, each of which has negligible weight. This is important information. It doesn't have weight. Which one of the following statement about the reading in the scale is true? This 2 pounds, so this one reads 10 pounds, this one reads 10 pounds, and the other also read 10 pounds because tension here in the wire is the same. Imagine there is a wire here instead of scales with negligible weight. So each scale will read 5, wrong. The top scale will read 0, the lower will read 10, why? The lower will read 0 and the top will read 10, why? Each scale will show a reading between 10, 1 and 10, such that the sum of the two scales is 10? No. Exact reading cannot be determined. No. None of the above, none of this is true because each scale will read 10. Because imagine that you have something here and the tension here in all the string will be the same. So the answer is E. Let's go to next. Two blocks A and B are being pulled to the right guys, along a horizontal surface by a horizontal 100 pull, as shown in the figure. Both of them are moving together at constant velocity. Constant velocity means the summation of the force equals 0. And both weighs the same. Okay? Both weighs the same. Which of the figures show correct free body diagram of the horizontal force acting on the upper block? On the upper block. Guys, we have here constant velocity, so the total amount of forces equals 0, right? Where is the forces in horizontal direction acts on A? No. No horizontal force acts on A, right? No horizontal force acts on A at all, as you see in the picture. So the answer is E. Let's go to the one next. Two blocks A and B are being pulled to the right, along horizontal surface by horizontal 100 pull. There is pull here on the B, right? As shown in the figure. Both of them are moving together at constant velocity. Constant velocity is summation of forces equals 0. And both ways the same. Which of the figure below show a correct free body diagram of the horizontal forces acting on the lower block? You can see the 100 force pulling effect on B. But the total amount of force equals 0, so there is a friction force here equal 100 Newton also. To get the total amount of force equals 0 because velocity is constant. So where is the answer? Letter B. Letter B is the answer. I hope you understand this one. Let's go down here. As shown in the figure, a woman is straining to lift a large crate, but without success because it is too heavy. We donate the forces on the crate as follows. B is the magnitude of the upward force being exerted on the crate by the person or the woman. Okay, so here is B upward. C is the magnitude of the vertical contact force on the crate by the floor, so it is also upward. This is C. And W is the weight of the crate, W here. How are the magnitudes of these forces related while the person is trying unsuccessfully to lift the crate. So W equal B plus C, or B plus C equal W. This is the forces here found here while the woman trying to lift unsuccessfully the weight. So where is the answer? The answer is A. Let's go to next. A push of magnitude B acts on a box of weight W. As shown in the figure, the push is directed at an angle theta below horizontal. So this is the box with weight W, and this is the force. We resolve it in x and y direction. Theta is here, so the one next to the angle get cosine. So P is the push force P cosine theta, and here P sine theta. And the box remains at rest. The box rests on horizontal surface that has some friction. There is a friction with the box. The normal force on the box, due to the floor is equal. The normal force be perpendicular upward. So this is N, the normal force. So N equal W plus B sine theta, because it is push force downward. So B sine theta plus W equal the normal force. Where is this answer? Letter D. W plus B sine theta. So the answer is D. That's enough for this video. We will complete the rest next videos. God save all of you, grade 12.